Options are Scala containers that can be used to test for the presence or the absence of a value. Options are containers, not technically collections. They offer a type safe alternative to specifying the null value in Java. The usual way in which an option is used by a function is to return the special value none if no proper result is available from the function. On the other hand, if a legitimate result is available, then that result will be returned in the form of an instance of the type sum. Sum and none are both values that can be tested against using pattern matching or other mechanisms in Scala. Let's check out how this works with a simple demo. We will also use this demo to illustrate the use of util.try, which is yet another common error handling mechanism in Scala. Let's start by defining a method called fraction. This method takes in two doubles, a numerator and a denominator, and it returns an option with a double. Inside the body of this method, it tests whether the denominator is equal to 0. If yes, the special value none is returned. If not, the division is performed and the numerator divided by the denominator are returned wrapped up in an option object. Notice how the return type option takes the type parameter double. This is how option objects provide type safety and error handling at the same time. The key bit here is the use of the special value none, which is returned when the denominator is equal to 0. This serves as a type safe way for this function to signal that something has gone amiss in the division. Let's first call this function. Let's invoke it with two legitimate numbers 22 and 7. The return value is sum, which means that the function was successful in getting a value. The sum object contains the value 3.14 followed by a number of decimal points. This is a successful invocation of the function fraction. Now let's go ahead and try this same function. Let's invoke it now with the denominator set to 0. And as you can see right away, the return value now is none. Because of the test in the body of our method for denominator equal to 0, this invocation of our function was unsuccessful. The real power or utility of option objects comes when we use them along with the method get or else. You can see now on screen that we have invoked the fraction function. 22 and 7 are the parameters passed in. After this invocation, we have specified a get or else method clause. Get or else followed by an expression. That expression will be the return value if the value from the option was none. In this particular case, there was no need for that get or else clause because the result was any. The result was a successful invocation. The value was 3.14. But if we try again and this time specify the denominator to be 0, none will be returned by our fraction method. And in that instance, the get or else method call comes into play. Our return value now is the string, oops, something went wrong. Option objects can also be used with pattern matching statements. The interesting thing there is that the values can be matched against sum or none. Let's first call our fraction method with 22 and 7 and then match the results of this using a pattern match. In this case, because the function invocation went fine, it is the sum clause which will be triggered. We have a value binding and we can store the result returned from the option in our value bound, that is pi, and so the return value of the statement as a whole is 3.14 followed by many decimal places. Let's now go ahead and repeat this experiment, but this time change the denominator to 0. If we now perform the same pattern match, it's the second clause which will be matched. This is the case none, and the return value here is the string something bad happened, and that is what gets returned by this expression as a whole. Let's now go ahead and explore a closely related concept, that of util.try. Recall that when we had discussed maps, we had mentioned that if you seek to look up a non-existent key in a map, the result will be an exception. Here we initialize a map with a bunch of state codes and then we look up a non-existent state called no such state, and the result is a java.util.noSuchElementException. Clearly, it's perilous to look up a non-existent value from a map. It's important for us to be prepared for this exception, and this is exactly where the util.try method comes to our rescue. We simply wrap util.try around whatever expression it is that we think might throw an exception. In this case, when we look up the non-existent key, we enclose that lookup within a util.try. The result will be a failure. This failure is an object that wraps around the exception. We can test for whether this operation or whether the result of the util.try was success or failure. Once again, we can do so using our favorite construct, pattern matching. You can see here that there are two cases. We can match for util.success, and we also include a value binding so that we can get the successful return value in the variable code, or we can match against util.failure. Once again, we have a value binding. The variable is called error, and this allows us to catch whether the operation was successful or not.